So the period of the merry-go-round is 4.0 seconds. It makes one revolution in 4 seconds. The radius of the merry-go-round is 1.2 meters. And we're trying to find the linear velocity of a child on the merry-go-round. So we know that the linear velocity equals the radius times omega, the angular velocity, and we know that the angular velocity equals 2 pi divided by the period. So we know that v equals 2 pi r divided by the period t, and this is going to equal 2 pi 1.2 divided by 4.0, and we get 1.885 meters per second. So this will be your answer for part A, the linear velocity of the child on the merry-go-round, and then it's asking us for the resultant acceleration, and we need to give units. So we'll first calculate the tangential acceleration, and this can be found by taking r omega. And one thing about this problem is that this is uniform circular motion. So in uniform circular motion, alpha, which is defined as the change of angular velocity with respect to time, this is going to equal 0 radians per second squared. We have a constant angular velocity, which means that the angular acceleration is going to be 0, which means that the tangential acceleration here is going to also equal 0 meters per second squared. To find the radial acceleration, we find this is going to be equal to r omega squared, and we know that omega equals v over r, so we can say that the radial acceleration is going to be equal to r v over r squared, and this is going to be equal to v squared over r. At this point, we can plug in. So a radial equals 1.885 squared. And this is going to be divided by r, 1.2. And we find that this is going to be 2.691 meters per second squared. Now, the resultant acceleration equals the square root of the tangential acceleration squared plus the radial acceleration squared. And we know that the tangential acceleration is 0, so we can say that the resultant acceleration is going to be equal to the radial acceleration. This is again equal to 2.691 meters per second squared. So this would be the final answer for the resultant acceleration. This would be one component, and a tan equals 0 meters per second squared. This would be your other component for part B. And that's the end of the solution. Thank you for watching.